In this module, we will be discussing landing performance. The discussion will include a definition of landing performance requirements, quick turnaround considerations, and advisory landing distance information. We will begin with a definition of the basic performance requirements for landing. We will now discuss the requirements which govern landing performance. These requirements include landing field length, approach climb, and landing climb considerations. The most limiting of these requirements defines the landing performance limited weight for dispatch. Let us take a closer look at each of these requirements, beginning with landing field length. Landing field length performance is developed from flight test demonstrated landing distances. These distances are measured from a height of 50 feet above the landing surface. The flight test landings are performed on a dry runway using an aggressive touchdown technique. Maximum manual wheel braking and speed brakes are used during the landing ground roll. Reverse thrust is not used or accredited in the flight test demonstrated landing distance. The certified landing distance on a dry runway is the flight test demonstrated distance plus an additional margin of 67%. For a wet runway, the certified dry runway landing distance is increased by an additional margin of 15%. The landing field limit weight is the maximum weight for which the landing distance available meets certified landing field length requirements. This weight accounts for landing flap setting, wind and pressure altitude, dry or wet runway surface condition, and airplane stopping configuration. The landing field limit weight does not directly account for runway slope, non-standard temperature, or approach speed additives. These considerations are protected by the margins used to define certified landing distance. We will now look at climb performance requirements for landing. These requirements are based on the certified approach and landing flap combinations for each airplane model. Climb performance limits for landing ensure a minimum climb gradient capability in the certified approach and landing configurations in case a go-around becomes necessary at any point during the landing approach. For a two-engine airplane, the minimum climb gradient required in the approach configuration is 2.1%. The approach climb configuration is based on the selected approach flap setting, with one engine inoperative, landing gear up, and the operating engine at go-around thrust. The approach climb capability is calculated at a speed not greater than 1.4 times the stall speed for the selected approach flap. The minimum climb gradient required in the landing configuration is 3.2%. The landing climb configuration is based on the selected landing flap setting with all engines operating and landing gear down. The speed used for landing climb calculations may not exceed the certified landing reference speed for the selected landing flap setting. The certified landing reference speed must be at least 23% greater than the associated stall speed. Landing climb capability is based on thrust available 8 seconds after the thrust levers are moved from minimum flight idle to the takeoff position. The most limiting of the approach and landing climb requirements defines the climb limited landing weight. For a 2-engine airplane, approach climb is typically the more limiting requirement, whereas for a 4-engine airplane, landing climb is typically the more limiting requirement. The climb limited landing weight for the selected approach and landing flap settings accounts for airport temperature and pressure altitude, as well as engine bleed for air conditioning and anti-ice. Ice accumulation on unheated surfaces is also accounted for when operating in icing conditions during any part of the flight, with forecast landing temperature below 10 degrees Celsius. For operators who are subject to Joint Aviation Authority regulations, there is an additional climb performance requirement for low visibility instrument approaches. The JAA minimum gradient requirement in the go-around configuration is the greater of 2.5%, or the published gradient for the specific airport, based on 1-engine inoperative and landing gear up. This requirement only applies to low visibility instrument approaches with a decision height of less than 200 feet. The performance requirements which we have discussed in this module and the maximum certified structural landing weight define the maximum allowable scheduled landing weight for dispatch. Landing performance information can be found in 2 separate sections of the operations manual. The Performance Dispatch section of Volume 1 provides landing performance information for dispatch in tabular format. The Performance In-Flight section of the Quick Reference Handbook provides advisory landing performance information for flight crew reference. This information will be discussed further in the Advisory Landing Distance module. The Flight Planning and Performance Manual is an additional source of landing performance data, which includes both dispatch information and advisory information in graphical format. The Flight Planning and Performance Manual includes landing performance information for some conditions and airplane configurations which are not available in the Operations Manual. We will now discuss the landing performance information that is provided in the Performance Dispatch section of the Operations Manual. This information includes landing fuel limit weight and landing climb limit weight. For JAA operators, go-around climb gradient capability is also included for low visibility operations. Quick turnaround limit weights will be discussed later in the Quick Turnaround module. Landing fuel limit weight information is provided in tabular format for one landing flap setting, with anti-skid operative, and for airport pressure altitudes up to 3,000 feet. 2 separate tables are used to determine the landing fuel limit weight. The first landing fuel limit weight table adjusts landing fuel length for the effective wind. The table is entered with landing fuel length available and wind component to determine the wind-corrected landing fuel length. The second landing fuel limit weight table is entered with wind-corrected landing fuel length, airport pressure altitude, and runway surface condition. To determine the landing fuel limit weight based on automatic speed brakes and all-wheel brakes operating. A weight adjustment is provided at the bottom of the table for manual speed brakes. For some airplane models, a separate weight adjustment is provided for brake deactivated performance. Landing climb limit weight information is provided in tabular format for one landing flap setting, the associated approach flap setting, and for airport pressure altitudes up to 3,000 feet. When a common approach flap setting defines the most limiting condition for the climb limit weight, multiple landing flap settings may be included in a single table. The landing climb limit weight table is entered with airport outside air temperature and airport pressure altitude to determine the landing climb limit weight for air conditioning packs on. Weight adjustments are provided at the bottom of the table for air conditioning packs off, anti-ice on, and ice accumulation on unheated surfaces. For JAA operators only, climb gradient capability in the go-around configuration is also included in the Performance Dispatch section of the Operations Manual. This group of tables can be used to evaluate JAA minimum gradient requirements for low visibility operations. The first table is used to determine reference climb gradient based on airport outside air temperature and pressure altitude up to 3,000 feet. The second table provides a gradient adjustment for weight. And the third table provides a gradient adjustment for speed based on the weight-adjusted gradient from the first and second tables. Finally, adjustments for air conditioning packs off, anti-ice on, and icing conditions are applied as appropriate to determine go-around climb gradient capability. The Flight Planning and Performance Manual includes additional landing performance information for dispatch, which is not available in the Operations Manual. The Flight Planning and Performance Manual includes pressure altitudes up to the maximum certified for landing, as well as limit weight information for each certified landing flap setting. Landing fuel limit weights are also included for anti-skid inoperative performance for airplane models which allow anti-skid inoperative dispatch relief. The Flight Planning and Performance Manual information is typically presented in graphical format. It may be necessary to refer to this information for airplane configurations and environmental conditions which are not available in the Operations Manual. In this module, we will be discussing quick turnaround considerations. First, we will look at the dispatch requirements and published data for maximum quick turnaround limit weight. We will then look at the advisory information which is provided for recommended brake cooling time. The quick turnaround limit weight is the maximum landing weight for which there is no mandatory minimum ground time prior to the next departure. For landing weights above the quick turnaround limit weight, a mandatory minimum ground time must be observed. This mandatory ground time protects against wheel fuse plug melt and loss of tire pressure during the next takeoff. As a certification requirement, quick turnaround limit weight is conservatively based on maximum manual wheel braking, with no credit for reverse thrust. Note, however, that quick turnaround limits must be respected in operation regardless of actual stopping technique. Quick turnaround limit weight information can be found in the Performance Dispatch section of the Operations Manual for one landing flap setting and for airport pressure altitudes up to 3,000 feet. The Flight Planning and Performance Manual provides information for all certified landing flap settings and airport pressure altitudes. Both documents use a similar tabular presentation format for quick turnaround limit weight. The quick turnaround limit weight table is entered with airport outside air temperature and airport pressure altitude to determine quick turnaround limit weight. Notes at the bottom of the table provide weight adjustments for slope and wind. The required ground time, which varies by airplane model, is also noted at the bottom of the table for cases when the quick turnaround limit weight is exceeded. For some airplane models, an alternate procedure for evaluating quick turnaround limits may be available. Operators may choose either the quick turnaround limit weight table information or an approved alternate procedure, if available, to comply with quick turnaround requirements. Advisory brake cooling information is provided in the Performance In-Flight section of the Quick Reference Handbook and in the Flight Planning and Performance Manual. This advisory information is intended to assist operators in avoiding brake problems that could result from repeated landings at short time intervals or a rejected takeoff. The first QRH brake cooling schedule table is entered with brakes on speed, airplane gross weight, airport pressure altitude up to 4,000 feet, and outside air temperature to determine reference brake energy per brake based on a single stop with all brakes operating. Note that the brakes on speed used in the table may be based on either indicated airspeed adjusted for wind or ground speed. The brakes on indicated airspeed during landing will normally be 5 to 7 knots lower than the approach speed when recommended braking procedures are followed. The reference brake energy per brake from the first brake cooling schedule table is used in a second table to adjust for the type of event and the wheel braking method used in the case of landing. A separate brake energy adjustment table is used when considering the effect of reverse thrust. The third brake cooling schedule table is used to determine recommended cooling time, either in flight or on the ground, based on total energy absorbed per brake. Additional procedural guidance is provided in the notes at the bottom of the table when in the caution zone or in the fuse plug melt zone. Note that maximum quick turnaround limits must be observed regardless of the guidance information obtained from the advisory brake cooling schedule tables. It is important to understand the differences between the published quick turnaround limit weight and recommended brake cooling schedule tables so that they are used correctly in operation. The quick turnaround limit weight is a regulatory requirement which may result in operational dispatch restrictions, whereas the recommended brake cooling schedule is advisory information, which provides additional brake cooling guidance to the flight crew. The quick turnaround limit weight restriction only guarantees that fuse plugs will not melt during the next takeoff. The recommended brake cooling schedule provides additional brake energy protection if it becomes necessary to reject the takeoff. Finally, the recommended brake cooling schedule provides the only means of evaluating brake cooling requirements following repeated landings at short time intervals, or a rejected takeoff. In this module, we will discuss the advisory landing distance information that is available to flight crews in the Performance In-Flight section of the Quick Reference Handbook. This advisory information includes auto brake landing distance, slippery runway landing distance, and landing distance for non-normal configurations that affect the landing performance of the airplane. Advisory landing distance calculations assume that the airplane crosses the runway threshold at a height of 50 feet and include an air distance allowance of at least 305 meters to touchdown. The use of maximum available reverse thrust is assumed during the landing ground roll when stopping performance is based on maximum manual wheel braking. It is important to remember that the published advisory landing distances are generally actual distances with no additional margins of conservatism. For JAA operators, the published advisory landing distance for slippery runways is the actual distance increased by 15%. The auto brake system commands a constant airplane deceleration during the landing ground roll for improved passenger comfort. Auto brake landing distance is provided in the Quick Reference Handbook as advisory information to assist in the selection of the most suitable auto brake setting for a given available field length. The Quick Reference Handbook tables provide actual landing distance on a dry runway from a 50-foot threshold height to a full stop based on auto brake setting and approach speed. These distances are valid with or without reverse thrust and for all landing flap settings. A second table provides auto brake landing distance adjustments for altitude, wind, and temperature deviation from standard day. These adjustments are ignored when the first table is entered with ground speed. When autoland is used in conjunction with auto brakes, touchdown should be assumed to occur 760 meters from the runway threshold. The increased air distance allowance can be accounted for by adjusting the advisory landing distance read from the QRH auto brake landing distance tables. Landing distance on slippery and contaminated runways is affected by the reduced friction between the airplane's tires and the runway surface. This reduced friction results in degraded wheel braking effectiveness and longer landing distances when using manual braking or when using auto brakes. Slippery runway landing distance is included in the Quick Reference Handbook as advisory information to assist flight crews in evaluating the expected performance of the airplane when landing on slippery runways. The QRH information is provided for one landing flap setting and for pilot-reported braking actions of good, medium, and poor. The first slippery runway landing distance table is entered with reported braking action and wheel braking configuration, to determine reference landing distance required. A second table provides landing distance adjustments for weight, airport pressure altitude, wind, approach speed, runway slope, and available reverse thrust. These adjustments are added as necessary to the reference slippery runway landing distance read from the first table. It is important to remember that the auto brake system may not be capable of producing target decelerations on slippery runways due to the reduced wheel braking effectiveness. We will now discuss the non-normal configuration landing distance information that is provided in the Quick Reference Handbook. This advisory information can be used to determine actual landing distance requirements for non-normal configurations and system failures that affect the landing performance of the airplane. Separate Quick Reference Handbook tables are provided for dry runway surface conditions and for reported braking actions of good, medium, and poor. The appropriate table for the reported runway surface condition is entered with non-normal landing configuration. To determine reference landing distance required based on the recommended final approach speed and landing flap setting called out in the non-normal checklist. Landing distance adjustments for weight, altitude, wind, slope, and approach speed additives are also provided. Remember that the published non-normal configuration landing distances are actual distances and assume a maximum effort stop.